the Moivre theorem for any integers. Okay, how to prove the Moivre theorems for any integers. Okay, and the theorem is this: the complex number I cos theta plus I sin theta, okay, all to power n. According to the Moivre theorem, this will be, this left hand side will be equal to the n will affect this one, that will be Rn, and then the n will be times this, the angle, times the angle, and that will be what? Cos n theta plus I sin n theta. Okay, so that's I want to show for any integers. Okay, so what the movie is saying is that we have this complex number in polar form to power n. Okay, according to that theorem, it's going to be this: the n will be on top of this, and then the n will come in and multiply the angles. Okay, times this, and we have this. Okay, so that's the objective of this aspect: how to prove that this is equal to this for any. We're going to start if z is equal to r cos theta plus I sin theta. Z square will be equal to z times z. Okay, and that's equal to r cos theta plus I sin theta, and then times r cos theta plus I sin theta. So this is the first one. The second one. So based on the multiplications of complex number, this will be equal to what? R squared. Okay, and when you are multiplying complex number, this will be equal to what? Cos theta 1, the first one theta, plus what? The second one theta. Okay, and then plus I sin theta plus theta. Okay, and this will be equal to what? This will be equal to R squared cos 2 theta plus I sin what? 2 theta. Okay, then we can also go on and generate z to power 3, which is what? Z squared times what? Times z. Z squared times z. So we now have we only have a value for this one, which is r squared, and to bracket cos 2 theta plus I sin 2 theta, and then times the z here, times that will be r to bracket cos theta plus I sin theta. Okay, so and that will be r3, this one times this one, and then we have cos 2 theta plus theta, 3 theta, then plus I sin 3 theta. Okay, so it goes on like that. We can also do the z to power 4, which is equal to z3 times z, z3 times z, and that will be equal to, we have the value for z, which is what? R3 cos 3 theta plus I sin 3 theta, and then times this one, which is r cos theta plus I sin theta. So if you do this, that will be this one times this one. Okay, and apply the rules of multiplications of two complex number, and that will be what? Cos 3 theta plus theta, that's 4 theta, and then plus I sin what? 4 theta. Okay, the results above shows that z1, z to power 1, okay, come back here, is equal to what? R cos theta plus I sin theta. Okay, then 2 power 1, and that will be equal to what? That will be equal to r cos theta plus I sine theta. Then Z2 will be equal to R cos theta plus I sine theta square that's part 2. Okay? And that will be what? That will be R squared. This will be cos 2 theta plus I sine 2 theta. Z3 will be equal to what? R cos theta plus I sine what? Sine theta. Then 2 power 3. That will be equal to what? R3 cos 3 theta plus I sine 3 theta. Okay? We can do one more. Z4. That will be to be the same thing also. And that will be R cos theta plus I sine theta 2 power 4. And this will be equal to what? This will be R 2 power 4 cos 4 theta plus what? I sine 4 theta. Okay? Therefore, this confirm Z 2 power n is equal to R cos theta plus I sine theta power n, and that will be equal to what? This one. Okay? So that's confirmed the roots. Okay? And this is what we call the Moivre theorem.